We look into the night sky and see billions of stars scattered across a black canvas. But what we see is only a fragment of something far greater. The observable universe, that is, the part of the cosmos our instruments can detect, is limited by one simple fact. Light takes time to travel. What we see today is not the universe as it is, but as it once was. Every galaxy, every cluster, every faint shimmer of light represents a story billions of years old. And that raises the question, what lies beyond what we can see? Scientists call it the cosmic horizon, a boundary beyond which light hasn't had enough time to reach us. It doesn't mean nothing exists beyond it. It only means we cannot observe it yet. The universe is vast and it's expanding faster than light can travel, which means some regions are forever beyond our reach. Those places exist, but they are locked away from our perception, hidden behind a curtain that no telescope can pierce. One of the most fascinating ideas in modern cosmology is that what lies beyond the observable universe might not be empty space, but rather a continuation. More galaxies, more stars, stretching endlessly. If you could somehow travel faster than light, you might see infinite copies of cosmic structures, regions similar to ours but completely unconnected. In this sense, our observable universe might be just a tiny bubble inside a much larger structure. Perhaps infinite in size, perhaps not. But some scientists go further. They suggest that what lies beyond could be more than just distant stars. It might be entirely separate realms, regions with different properties, different physical constants, even different dimensions. This is where the idea of other universes begins to take shape, not as fantasy, but as a possible extension of known physics. The idea of multiple universes, or the multiverse, isn't born out of imagination alone. It's a serious hypothesis that emerges naturally from several scientific theories. One of them comes from cosmic inflation, a model that suggests the universe expanded incredibly fast in its earliest moments. During this expansion, some regions might have stopped inflating while others continued, creating isolated zones of space-time, each with its own conditions. In this view, our universe could be just one of countless regions that formed within a larger, ever-expanding reality. Other theories point to the strange behavior of quantum particles. At the smallest scales, reality behaves unpredictably. Particles appear, disappear, and exist in multiple states at once. Some physicists propose that every possible outcome of these events might occur, but in different realities. That would mean somewhere, in another universe, events unfolded differently from ours. Not in fantasy, but as a real, physical outcome of the laws of nature. But how could we ever prove such things? We can't directly observe these other universes if they exist. They lie beyond the limits of light and measurement. Still, indirect clues might exist. For example, some cosmologists search for patterns in the cosmic microwave background, the faint afterglow that fills the universe. If our universe ever interacted with another, those collisions might leave subtle traces, circular imprints or distortions in the data. So far, no evidence is definitive, but the search continues. There's also the question of space itself. Does it have an edge? Most evidence suggests it doesn't. Space might curve back on itself, like the surface of a sphere. You could travel in one direction forever and never find an end. Only return to where you started after crossing unimaginable distances. This challenges our sense of boundaries, making the concept of beyond itself uncertain. If the universe is finite but unbounded, then what we call outside may not even exist in the way we imagine. And then comes the mystery of dark energy, the unseen force that drives the universe's expansion. We know it's there because we see galaxies moving away faster and faster, but we don't know what it is or why it exists. Some theories suggest that dark energy might vary across space, possibly stronger in other regions beyond what we can see. If true, then the universe beyond our horizon might look very different from ours. more chaotic, more unstable, or perhaps calmer and colder. What makes this mystery so compelling is that every discovery leads to new questions. The more we learn about the universe, the more we realize how little we truly know. We build instruments to look deeper into space, yet what we find only stretches the boundaries of our ignorance further. Each new observation extends our horizon, but the unknown grows with it. Infinite, unreachable, humbling. It's possible that we will never know what lies beyond the visible universe. Our physics, our senses, and even our tools might simply not be equipped for it. But that doesn't stop us from wondering, because the question of what's beyond isn't just about distance or stars. It's about the limits of understanding itself. The human mind was built to ask, to explore, to imagine what exists past the edges of the map. Maybe the boundary of the observable universe isn't a wall, but a mirror, one that reflects our own limitations. We stare into the unknown, not to conquer it, but to understand our place within it. And even if we never cross that boundary, even if what lies beyond remains forever hidden, the search itself might be the greatest journey we'll ever take.